Welcome to 7.4 Trapezoids and Kites. First, let's talk a little bit about trapezoids. The trapezoid is quadrilateral with only one pair of parallel sides. The parallel sides are called bases. The not parallel sides are called legs. The two angles that share a base of a trapezoid are called base angles. So here we have our pairs of base angles on the bottom, pairs of base angles on top. You have your legs and your bases. So that's a trapezoid. A couple of properties of trapezoids. First, a trapezoid has exactly two pairs of consecutive angles that are supplementary. The base angles are not supplementary. The pairs of angles that are on the typically left side and right side of the trapezoid will be consecutive, and they add up to 180. Okay, so here angle R and angle T add up to 180, angle A and angle P add up to 180. Second, the length of the midsegment is the average of the lengths of the bases. What this means is you add the bases together and divide by 2. So our midsegment formula is base 1 plus base 2 divided by 2. So we're going to add that to the middle part trapezoid there. Exactly one pair of parallel sides and two pairs of consecutive angles are supplementary. The midsegment formula is also on this flowchart already added. There's a special type of trapezoid. It's called an isosceles trapezoid. An isosceles trapezoid has legs that are congruent. So the parallel sides aren't congruent, the legs are. So what it looks like here, you have your pair of parallel sides, and you have your legs that are congruent. Property of isosceles trapezoids is that each pair of base angles are congruent. So the base angles are congruent, and the diagonals are congruent. So here AC is congruent to BD, and up top your base angles, angle T and P are congruent, angle R and angle A are congruent. So we're going to add that underneath trapezoid is isosceles trapezoid. Non-parallel sides are congruent, which legs are congruent, diagonals are congruent, and base angles are congruent. So it's all about congruent in isosceles trapezoids. Our next shape is called a kite. A kite has two pairs of consecutive sides that are congruent, but opposite sides are not congruent. So this is not a type of parallelogram. So consecutive sides are congruent. Properties of a kite: its diagonals are perpendicular, and one pair of congruent angles are congruent. So in this, BE is congruent to DE, and angle ABC is congruent to angle ADC. Notice that angle BAD is not congruent to BCD just because those are completely different angles. So you got one pair of congruent angles and diagonals are perpendicular. So we're going to add that here to our last box, kite. Both pairs of consecutive sides are congruent, opposite sides are not. Diagonals are perpendicular, and exactly one pair of opposite angles are congruent. The trapezoid midsegment formula, like we said earlier, B1 plus P2 over 2. We're going to see some examples of these. So the angle measurements, CDEF is a trapezoid, isosceles trapezoid, so we know that base angles are congruent. So angle F is 65 degrees. Because it's a trapezoid, it adds up to 180, so we do 180 minus 65 to find angle D and E. So again, angle F is 65, 180 minus 65 gives us 115. So angle D and angle E are both 115 degrees. Our next example, here we have midsegments. So we're going to add the bases, 4x minus 10 plus 8, and then we're going to divide by 2. And it equals the midsegment, which is x plus 2. So now we combine like terms, negative 10 and 8 make negative 2. And we're going to take half of 4x minus 2, which gives us 2x minus 1. Subtract x from both sides, add 1 to both sides, x equals 3. For a kite, we know that diagonals are perpendicular, so angle 1 is 90 degrees. Then we have 52 up there. We also know that angle 2 is 180 minus 90 minus 52, and that angle 3 is just the 52 degrees because it creates two congruent triangles. So angle 2 is 38 because 180 minus 90 minus 52. And angle 3, again, since these are two triangles that are congruent, then angle 3 is just 52. The idea is it was bisected. Okay, that is it for trapezoids and kites.